Assalamu alaikum. My name is Amit Tayer, and the name of our final year project is Power and Health System. Our supervisor is Dr. Abdul Khaliq, and co-supervisor is Engineer Ishaq Talib. The name of my group members are Qasim Maqsood, Aqib Mahmood, Muhammad Hamza Ilahi. Introduction. As we all know that Pakistan faces a loss of billions of dollars due to the power theft. So to provide a solution to this problem, we devised a system that prevents the theft as we nobody wants to pay for the service they have not used. If we want to simply describe the concept of our system, we can say that it calculates the power that goes out from the transformer of a certain locality and the sum of powers that enters the houses of the legal users of that locality. Of course, there will be some losses naturally, but we will set a threshold to overcome them. If both the input and the output powers are approximately equal, then there will be no theft and vice versa. And if theft is detected, then the local monitoring office will be notified. After the alignment with our supervisor, we redefined the scope and shifted from the hardware towards totally software simulations because we didn't have the ability. First of all, we didn't have the ability availability of the hardware components due to pandemic, and we weren't able to. And secondly, we weren't able to use the labs as we all know that life was a standstill due to pandemic. So therefore we went for the best option available after the analysis with our supervisor. Thank you.
Bismillahirrahmanirrahim. My name is Qasim Maqsood and I'm going to talk about the commercial worth of our project. Energy theft is a worldwide issue and this white collar crime is committed elsewhere irrespective of the economic stability of countries. In 2013, it was placed on the record in the Senate of Pakistan that in the last 5 years, Pakistan had lost rupees 90 billion in electricity theft and line losses. Accurate metering and billing of actual energy consumed by consumers is integral to commercial management of an electric utility. Electricity theft is a grave problem across the globe. Improvement in aggregate technical and commercial losses in phased manner is very important for financial and technical viability of distribution companies in deregulated environment. The major challenge is to identify the location of the theft and estimate the amount of energy being stolen. The objective of this project is to analyze the theft of electricity and minimize its impact on economic of the regulated companies, consumers and societies as a whole. Components used in our project are commercially available in the local market and some are not which are to be shipped from somewhere else. Due to pandemic online shipment of components were very difficult to acquire. So most of its implementation is software based which make it much cheaper and is reliable at the same time. As electricity is very important in every aspect of life, so electricity theft does not consist only of generated electricity being stolen. Infrastructure is much more than just an inconvenience. In some parts of the country where some clinics do not have generators, a power cut can disable critical machinery and endanger the lives of patients. The same can be said for schools where learning can be disrupted due to lack of electricity, which is being stolen. Productivity in businesses comes to a grinding halt when there's a power cut and ultimately jobs are put at a risk. Electricity theft has a terrible ripple effect across many areas of the society. All this can be avoided if accurate measurements are taken using power anti-theft systems, which helps in economic stability and so that people don't have to pay for the expense of the others who are stealing their electricity.
I am Aqib Mahmood. The end result of our project is to design and simulate different methods and to come up with practical solution to help the power saving and economic situation of our country as well as in the society. So here is the simulation part in which we connect different nodes via GSM and through Arduino, in which uh, uh, we use the GSM commands through Arduino, in which we transmit the message and receive at the another node as the message received at the another node. Here in this part, we generate the impulse generation through which we have to measure the power. The on time of here the impulse is fixed as usually in the most of the energy meter the on time is fixed, and the off time vary with the connected load. After the signal conditioning, we fed this signal like the variable PWM into a controller, through which we programmed the controller to measure the power from pulses. After that, we displayed it on to the LED LCD. Here is the simulation part in which one side is the meter side, and the other side is the pole side. Here in which we have to protect the line voltage from the theft. So now we connect these nodes like the energy meter node and the pole node via GSM through controllers. Here is the another scenario in which we have to protect the line voltage through pole to pole, like from one pole to another pole we have to protect the line, through in which we name the one side as the source side and other side as the consumer side, for the sake of the understanding of the messages. So here the three loads are illegal load connected. Now at that time they are not connected, they are open. After programming successfully uploading on the controller, we run the simulation, and as soon as we connect one of any illegal load like inductive, capacitive, or any resistive load, the theft is detected, through which as we connect the inductive load here, the theft is detected at on the terminal. Like as you can see, we again connect and the theft is detected here. So here is the programming part. We upload to different controllers we can connect on the simulation. Here is the part in which we measure the current through a line, and we use for our purpose. Here is the whole overall scenario of the simulation, in which we have the pole power, source power, consumer power, and the pulses generation through meter. Okay.
My name is Muhammad Hamza Ilahi, and now I will explain you the working of overall scenario using the flow graph or block diagram. First, the load will be connected to the energy meter and the code will be uploaded in Arduino. After that, the value of LDR or any sort of optical sensor value will be measured. If it is less than the threshold, the optical sensor will be turned off, and if its value is higher than the threshold, it will start counting the units and the final output value will be displayed. In the Gantt chart, we have completed the project in the time given to us according to the situation of the pandemic. We have completed our FYP based on the ways our FYP scope was realigned with our supervisor. Thank you.
Assalamu alaikum. I am Akim Mahmood, and with my group fellows Sameet Tahir, Hamza Ilahi, and Qasim Maqsood. We are the team member of final year project, supervised by Dr. Abdul Khaliq and co-supervised by Sari Saab. Uh, as due to the previous pandemic situation and due to lockdown, we reschedule our project and limited our scope uh, with supervisor, and we stick to the only software and not to go to hardware. So after alignment with our supervisor, we designs different simulation, and after all we overall design a final simulation of power anti-theft system. So now come to the simulation, and here is the circuit diagram which is for the PWM generation, in which we generate the PWM. This is the actually analogy of the signal which we in practically from the energy meter, like wise in the form of PWM, like we get from the sensor. Here in the simulation, we generate this signal just like as shown in the digital oscilloscope, like it is just like that. uh, Let me show, like it was similar to that signal, like the on cycle of that signal would be fixed, and the uh, off time would be vary from the different loads. Like if we connect a higher load, the off time will be reduced, and if we similarly connect the maximum load, the off time will reduce, and the more pulses will be generated. And through this we measure these pulses, and we here design measuring through controller, and after that measuring these pulses we display on the LCD. Here is the coding part of the meter monitoring, in which we calculate the power of the meter and shown on the LCD here. And this is the meter side, this whole side. And after that, here is the wireless system on both side, on the energy meter side as well as on the pole side. So in the pole side we measure the single phase uh, energy through the sensor, and after rescheduling that signal we fed into controller and measure that power. And here we see that the power is shown here. After that we wirelessly connect these two devices, like this is the GSM at the side of the meter side, and this is the at the pole side. Here in this wire, in actual scenario this would be wirelessly, but in the simulation this would be a wire through connection, in which we connect RX and TX respectively. On the other side, here we protect the line to line protection, in which likewise from one pole to another pole. Same thing as previously we made the power, and here you see, like we consider this as a source side, in which the power is being monitored and measured and calculated and displayed on the LCD, and transmitted through the GSM wirelessly. Similarly, on the uh, load side as well. Now, here, if we let me show the values here. So now, as you can see, this is the consumer side power, and this is the source side power. Now, if I connect one of the illegal load, and we consider these three loads as illegal loads, like you can see resistive, capacitive and inductive loads. Now if I connect this load, like this would be an illegal load connected to the lines. Now let me connect this load and check out either the message will be displayed or not. It should be displayed like that. The theft is detected, must be shown here. uh, as it is shown previously, but maybe due to some reasons not showing right now. As you can see, it is not updating here the consumer power, so maybe it will take time, some due to load on the CPU. Likewise, as you can see, theft is detected. Consumer power would be less now. So here is the whole overall simulation you can see. So this is our project. Okay.